Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, today's lecture is about a new topic which is part of the 2025-2027 exam series, and this topic is about decimals and fraction. This is known as recurring decimals. Now, it is considered a tough topic, so let me make it easy for you. Now, let's look at these examples. 1 over 2 can be written as 0.5. 1 over 4 can be written as 0.25, and you are all well aware of these fractions. Now this is an exact decimal because it stops right over here. This is given correct to 1 decimal place. dp stands for decimal place, and this is 2 dp, 2 dp, 1 dp and 3 dp. Now let's look at these. Let me convert these fractions to decimals using a calculator. So go ahead, grab your calculator and let's divide. So if I take 1 divided by 3, this comes out to be 0.333 and it keeps on going. 4 divided by 9, that is 0.444 and it keeps on going. Now let's divide 57 over 99. This is 0.575757 and so on. Let's divide 586 over 999. That is 0.586586 and it keeps on going. Now these are fractions which do not stop. They keep on going. These are rational numbers, rational fractions, because the numerator is an integer and so is the denominator. But the fractions keeps on going. Now in this one, the 3 keeps on repeating, the 4 keeps on repeating, the 57 part keeps on repeating, and over here 0.586, the 586 part keeps on repeating. Now for simplicity, what I can do is that let me write down this thing as 0.3 and let me put a bar at the top. Or let me write down this thing as 0.3 and let me put a dot at the top. What it means is that this part after the decimal will keep on repeating, as we can see right over here. So over here, let me write the next one. This is 0.4 and a hat or a bar at the top. This is 0.57, a bar at the top. This is 0.586, a bar at the top. Now these decimals that we are dealing with, these are called recurring decimals. And over here, it could be a digit or a group of digits. Over here, basically, I have written down what it means. A digit or a group of digits, it repeats forever. There is a pattern to it. It is periodic. So what are we focusing on? We are focusing on converting recurring decimals into fractions. So let me write it down. The focus is on conversion. The conversion from recurring decimals into fractions. Now there are some more examples that are left over here. Let's focus on this one, 32 over 90. This is 0.3555. 461 over 90. That is 0.51 and then 222. Keeps on going, keeps on going. 541 over 990. That is 0.5464646 and so on. And this big number, 5737 over 9990. This is 0.5742742 and so on. Now it is slightly different. Yes, these are also recurring decimals, but over here, this digit is not repeating. This 5 is being repeated. Over here, 51 is not being repeated. This 2 is being repeated. Over here, this 0.5, this 5 after the decimal is not repeating, but 464646, that pattern is there. That periodic type of thing is there. Over here, this 5 is not repeating, and this time 742 is repeating. So therefore, what I can do is that let me write this thing as 0.35 with a bar at the top. Over here 0.512 with the bar at the top. We put a bar where? At the repeating part, whether it is one single digit or it's a group of digits. Over here I can write this thing as 0.5464646. So let me remove this 46 extra over here and let me put a bar at the top. Over here this is 0.5 and then 742. This part is being repeated and we are writing it over here. So now a little bit more information. That is a decimal in which everything is repeating after the decimal, whether it's 1 dp, whether it's 2 dp, whether it's 3 dp. These 4 examples are examples of pure recurring decimals. And what about the other 2? That is a combination of both. This digit is not repeating, this is not repeating, the 1 is also not repeating, this 5 is not repeating, this 5 is not repeating. So this is an example of a mixed recurring decimals. So now what is my objective? My objective is to teach you thoroughly in and out how do we convert a recurring decimal into a fraction, whether it's a pure one, whether it's a mixed one. So let me do 6 worked examples on the following pages. That is about conversion from recurring decimals to fractions. Let's look at the first one. I have a number 0.4 and the focus in all of these green labeled question, that is I am focusing on converting these recurring decimals into fractions, and that is the objective and that is the new thing in the syllabus. So let's look at 0.4. This 0.4, let me use the symbol, let x is equals to 0.4444 and so on. Let me expand it out. Now I'll be playing with multiples of 10. So remember this thing. I'll be playing with multiples of 10. That means I could be multiplying by 10, I could be multiplying by 100, I could be multiplying by 1000, I could be multiplying by 10,000 and so on. And you will soon learn why exactly I'm multiplying by 10 in some case or 100 in any case and so on. So let x is equals to this thing. Let me multiply with 10. So 10x is equals to 4.4444 and so on. Now let's focus on this. This part after the decimal and this part after this decimal, is it the same? That's the decimal, that is the decimal, it's the same. That means if I want to go ahead and do some subtraction, this part and this part will cancel out. I hope you're getting the idea what I'm aiming at. That means let's do the subtraction. 10x minus x, this is equals to 4.444 minus 0.444. Of course, this is repeated. Of course, this is repeated. So the repeating parts would cancel out, would be subtracted, and 4 minus 0 is 4, and 10x minus x, that is 9x. 9x equals to 4. Therefore, x is 4 over 9. And it was there a little bit above. So let me go over there. There it is. This is worked example 1. 4 over 9 was written as this. I converted it back. So I'll be using these examples. Just have a good look at it. Take a screenshot if you want to. Let me hold the image. Take a screenshot. That's the first one. Take another screenshot. I'll be doing the examples out of these. So now first example is done and dusted. Give yourself a star if you have understood it thoroughly. Now the next example. This is 0.57. So let me write let x is equals to 0.575757 and so on. Let me multiply this time by 10x. 10x is equals to 5.7 and then 5757 and so on. Now focus over here. This time if I do the subtraction, it's of no use. Why it's of no use? Because these two things are different. This one is different from this one. Can you look at it closely? This is 57, 57, 57. This is 7575. This is not the same. That means I have to work in multiples of 100, and now you'll be getting the idea. The idea is, let me multiply it first, 57.5757 and so on. The idea is make sure that you have the exact same thing after the decimal. So let me just change the color because the purple and the pink, they almost look the same. Let me use a green color right over here. So that's the marker. That is the thing. So this is different. Now focus on this. This thing after the decimal, this thing after the decimal is the same. So this time I'm working with x, I'm working with 100x. I'm working with this number, I'm working with this number. So let's do the subtraction. 100x minus x, that is 57.5757 and so on, minus 0.5757 and so on. So when I do the subtraction, what do I get? I get a 99x over here. I get a 57 over here. Make x the subject because that is what you are looking for. You are doing the conversion. So x is equals to 57 over 99, and that is how you do the conversion. So it's a very, very interesting topic. I mean, in maths, you have to take interest. You get a feel, a sense of achievement. Once you get that sense of achievement, once you have your concepts clear, concise, and you are speaking and writing and working, all these things, speaking, writing, working in a coherent manner, you are all set for your desired grade, which is an A star, and I'm making you work towards that. So let's get started with the third example. Now this time this is 0.586. Again, let x is equals to 0.586. Let's multiply with 10, 10x, and let me write more. 586, 586, 586, because this is being repeated. So 10x is a 5.86, 586, 586. Let me write 100x, that is 58.6, 586, 586. Let me write 1000x, that is 586.586.586. No, point is already used. Now focus on this. Let me do the highlighting. This is 586, 586, 586. This one is 86 and then 586. This one is 6586. This one is the same as the first one, that is 586. Now you get the idea. So now let's recap what we are trying to do. We are trying to do that since it was just regarding the first thing, that is the 10th value. So we multiplied it with 10th. When it was the two other values, the 100th value, we multiply with 100. When it is about three values, the 1000th value, we multiply with 1000. So that is the bottom line of the story. You don't have to ratify it. You have to understand the concept. So now let's work with x and 1000x. Let's work with these two. So therefore 1000x minus x, that is 586.586, 586 minus this thing, which is 0.586, 586 and so on. So let's do the subtraction. 1000 minus x, that is 999x. 586 minus 0, that is 586. Make x the subject. 586 over 999, that is the answer. And also this example was right over there. I can just make you double check. So there it is. This is 586 over 999. That is 0.586, 586, 586. That's right over here. So three examples are done. So this is, I think, worked example 2 that we did. And this is worked example 3. So three examples are done. So now let's move to the fourth one. Now the fourth one is 0.35. Now this is a mixed recurring decimal. Let x equals to 0.3 remains as it is. And then we have 5, 5, 5, 5, 5, 5 and so on. So now let's multiply with 10x. 10x is 3.555 and so on. Will it work? I don't think so. It won't work. Why? Because this thing is this and this thing is different. And let me use a green color right over here. Now this time let me multiply with 100. 100x is equals to, this is 35.555 and so on. Yes, you have hit a jackpot. This thing is the same thing as above. So this part, the 555, and this part is the same. So let's look at worked example 4. This is 0.35 and the 5 is the repeating part. That means if I write it, I'll write let x is equals to 0.3 and let me write this thing in red color. That's 555. That keeps on going. Again, we have to play with multiplication by 10. Let's multiply by 10 first. 10x, that is 3 point, and let me use the same red color. That is 555 and so on. Now think over here. These two are different, so subtraction is not possible. Let me multiply with 100. If I multiply with 100, therefore 100x is 35 point, and then the red part 555 and so on. Now over here, if I compare the first and the second, it was not working. If I compare the first and the third, still it's not the same. So what is exactly the same? The exact same part is this and this. That means this time I'm dealing with 10x and 100x. So let's subtract these two. So therefore, when I do the subtraction, therefore this is 100x minus 10x. That is equals to 35.555 minus 3.555 and so on and so on. So this 35 and this 3 subtracts. It gives us 32. 100 minus 10, that is 90. X is 32. Therefore, x is 32 over 90. That is how this question is done and dusted. Let's move to the next one, 0.512. This time I'll write let x is equals to 0.51 and let me write 222 because that is the repeating part. Again, let's play with multiples of 10. First of all, 10x, that is 5.1, and then I have this 222 and so on. Again, these two are not the same after the decimal. Let me multiply with 100. 100x is 51.222, and let me just change the color over here so that you can have a good look at it. Now, is subtraction possible? This is different, this is different, this is different, all three are different. Let me multiply with 1000 now. 1000x is equals to 512 point, and then it's 222 and so on. Let's focus on this. So I see this after the decimal, these three are the same and it keeps on going. After the decimal, these three and more are the same because it keeps on going. Therefore, this time I am working with 100x, I am working with 1000x, and then I am working with these two. So let's do the subtraction. So therefore 1000x minus 100x, that is equals to 512.222 keeps on going, minus 51.222 keeps on going. So therefore 512 minus 51, grab your calculator, this comes out to be 461. 1000 minus 100, this comes out to be 900. X is there. Make x the subject, that is 461 over 900. I just missed the pin, slipped the pin. So this is 461 over 900. And let's move to the last worked example. And these 6 worked examples are more than enough to make you solve any recurring decimal question. So let x is equals to 0.5. And what do we have? 742, 742, 742, and so on. So the recurring part is this, the 742, the 742, the 742. Now again, let's play with multiples of 10. First of all, 10x, that is 5 point, and this is 742, 742, 742, and so on. And let me write 100x over here. That is 57.42, and then 742, and then 742. And let me write 1000x over here. That is 574.2, and then 742, and then 742. Now wait for a second. Why am I going to this much length? Because this and this and this and this, they all are different. So I need to just multiply once more. So therefore 10,000x is equals to 5742.742742 and so on and so on and so on and so on. Now let's focus on this. Which ones are the same? What I see over here is that the 742 part in this 10x and in 10,000x this part is the same. So this time I'm dealing with these two. So therefore 10,000x minus 10x, that is 9990x. This is equals to 5742. This part is the same. This part is the same. 5742 minus 5. 5742 minus 5. This comes out to be 5737. Therefore, x is 5737 over 9990. So that is how this thing is done. And all these examples are from the first page. So 5742 and this 512 and this 0.35. Let me show it to you. So there it is. I think this one is 0.35. I think this one was worked example 4. So this is worked example 4. And then we have 0.512. This was worked example 5. And then the last one was this. That was worked example 6. So I have solved 6 thorough works example to make you understand what recurring decimals are all about. That is the effort from my part to make sure that O-level math people, they get the best possible grade in the upcoming exam. Stay tuned for more content and do let me know how much you liked this particular video and other videos in the comment section. Take care, everyone.